Welcome to this Fire Talk with me, Gabriel Paues from SailSpring, and Lars Larson from Elasticist. Me and Lars works as cloud architects, me at SailSpring, helping our customers to use our cloud services as effective as possible, while Lars is working at Elasticist, helping customers migrate from Azure or AWS to their compliant Kubernetes platform. This will be an interactive session where you will be able to ask questions. So just raise your hand in Zoom if you want to pose a question or write a question in the chat. And don't worry if you drop out, because this session will be recorded for later so you can view it afterwards. Lars Larson, you wrote a blog post called Top 5 Cloud-to-Cloud Migration Woes. That was the second most read post at CNCF, the Cloud Native Computer Foundation website last month.
Yeah.
And I think personally that was a great read because it underlined things that I have seen myself helping customers migrating to us. And your post consists of 5 topics. In this Fire Talk, we will go through them one by one. But first, I just would like to back up a bit and try to understand why you should go multi-cloud, why you should want to migrate to another cloud provider, or to make your services more agnostic to the cloud provider you're running among. What do you think are the reasons, Lars, for that?
Yeah. Well, you had a webinar about this, didn't you? I mean,
yeah.
I think there are many, many reasons. One of them perhaps being specifically very interesting now due to the summer of 2020 Schrems 2 ruling, which makes it rather unclear, let's say, whether you can actually use American-owned cloud providers to handle personally identifiable information in accordance with GDPR. So now lots of companies are thinking, okay, maybe we need to process that type of data in a European-owned cloud instead. And then they have to start looking because all the major obvious choices for cloud providers, you know, your Googles, your Microsofts, your Amazons, Oracle to some degree, you know, all those, the really big and obvious choices, they're all American companies. So now all of a sudden, people are realizing that, oh, maybe we need to start migrating to a European alternative, or for disaster recovery purposes, even if you know for a fact that you can use, you know, these 2 cloud providers or whatever, you still need to figure out, how do I technically do that? So how do I ensure that my deployment works just as well with this cloud provider as with this other cloud provider?
Yeah. And the easiest way to understand that, or to really know if that's possible, that's to do an actual migration from one cloud to the other, because then that's when you're going to see those differences. For me, it's just what I've seen is just really important to be able to have an independent design of your services, so that you know that you are not having any hidden dependencies or stuff like that. And then also, of course, some kind of better point of negotiation, that you don't always have to say, yeah, we need to use you because we have built our services for your service.
Yeah, excellent. Yeah, exactly. That's the vendor lock-in that we've been hearing about so much. And people know that that's a factor, but I'm sure you've talked to customers that have really felt this pain, that they've realized that, oh, we've been rather locked in to one platform. And that, of course, makes it a bit trickier to migrate, but it's very worth it because, as you said, if you're not independent, you're dependent, and then you don't have any room for negotiation, really.
And also if you're locked in, then also we get into a little bit about the pricing models and stuff like that. What can you say about those?
Yeah, I think that's very, very interesting, and that's a good question that you bring up, because the pricing models, they vary a lot between different cloud providers. So all cloud providers will tell you that you pay per use, you pay down to the minute or hour or second or whatever time resolution, and you just pay for what you use. But I mean, pricing can be so complicated that it's actually very hard to realize how much you're going to spend ahead of time. So, I mean, if you have a quite mature cloud deployment, of course you can look up at your bill afterwards, because the cloud providers, they're very good at telling you how much you owe them, right? I mean,
yeah, of course.
It's their business. So obviously they're very good at that stuff. But to actually figure that out ahead of time can be quite a challenge, especially then if you're moving from one to the other. Because, yeah, it's not just, I'm using this many CPU hours usually. It can be very complicated. How much network do you use, or how many log entries per time unit are you actually processing, et cetera, et cetera. But I mean, can you say something about the SafeSpring pricing model? Because I found that to be
the SafeSpring pricing model is pretty flat. Yeah, but it's just we have the CPU per hour and the memory per hour and just like consumption based.
Yeah.
So whatever you create, you know that's what it's going to take. We don't have any kind of on traffic or kind of other services that you can see when you have per log entry, like you said, or per message sent through a queue service and stuff like that. That is things that they can be really appealing in the beginning, because you say, okay, so this is just like a little amount of money for every queuing message I'm sending through this service.
Yeah.
But then you don't know in beforehand how many messages will my application actually render.
No.
So you can actually it could look so appealing from the beginning, but then when you start looking, and also it's kind of also putting over the responsibility to you to make your application, well, be a little bit more sparse with amount of messages and stuff like that, if you want to cut down the costs.
Yeah.
That can be hard. In our services, it's more like you do downsize the machines if you think that you don't need as many resources. So we think that's better to be a little more transparent with those things.
Yeah, absolutely. I mean, that's easier to understand. I mean, I've personally seen, say, misconfigured service just spraying tons of log entries into a pay-per-use logging service. Of course, that's happily just going to ingest all that data. But then the bill afterwards, that was not such a happy experience. So it's much easier if there's some kind of obvious limit, like, I'm actually flooding this system that was actually designed to be able to handle the normal amount. Wonder what's going on here, rather than finding that out at the end of the month when you owe money for it. So yeah, the problem is that it can be very, very difficult to compare pricing models. So here is something where you really need to figure out what services do we actually use, and how much would that cost in a different cloud. And I mean, if you're migrating from one where you have all these kinds of services and you pay per all kinds of interesting ways of figuring out resource usage, to, for instance, SafeSpring then, where it's basically virtual machines. You know the capacity. Here's what they can do. This is what you pay for it. I mean, to me at least, that sounds like a much simpler model to get right.
Yeah, we think so too.
Yeah.
So okay, so that's mainly also because if you're going from one cloud provider which has a little bit more advanced pricing structure to another that has an advanced pricing structure, then also because then it's going to be hard to map the different usages and how that kind of going to hit the costs at the bottom line.
Yeah.
Okay, so that's the pricing models, but then there are other things also that are kind of the vendor locking we're talking about. You have cloud vendor specific integrations. What can we say about those?
Yeah, well, I mean, there are, again, that is, so unless you operate on the level of virtual machines where you actually deploy software, maybe somebody manages for you, or you manage it yourself. But if you go away from that model and you go into the as a service model, where like, oh, all our logs wind up in this service, all our messages in a message queue wind up in this service, etc., etc. That means essentially you're tying yourself in to that cloud provider, like we just talked about. So, I mean, that means that your application has been custom made to run at a specific cloud provider, really. And it's going to take quite some engineering to get you out of that situation. So that's that whole dependence thing that we talked about.
This can be a little bit sensible subject, because that's kind of the promise of the cloud, that you should be able to just, it's time to market enabling. It's just so easy to get things running when you run in AWS, for instance. There are so many knobs that you can click and get a whole quite advanced service just running, but then the backside of that is, of course, that if you do all the integrations in your applications that rely on these services, then you're going to notice that when you try to migrate out, that, okay, so this service actually is used pretty heavily throughout our application. So we need some development work to get rid of that dependency, right?
Yeah, absolutely. Yeah. And again, basically make a list, really understand what you use, and figure out what the alternative would be if you migrate. So if you migrate to a cloud provider and you want to integrate with their services because you think that the tooling that will give you is going to be good for you in some way because it's going to support your processes, that's great. Maybe consider going to open source components instead, so that the next time you have to migrate, or just so that you don't get this lock-in effect. But really, you need to figure out what you use.
Yeah, and you actually can go halfway here, because you can actually be in a cloud service provider that has all those services, and then you can start one by one and doing them yourself with virtual machines instead, of course, and stuff like that, or containers. And then, because then you will need to rewrite your application to those you host them more or less yourself, but you get more control, and when it's time to migrate out, you know exactly what's running there, right?
Absolutely. And I mean, for certain things, maybe you have so many other systems that depend upon your integration with this one, say an identity provider, right? So, I mean, that can be oftentimes one of the more difficult things to migrate out, I'd say, because if you have an organization, you've been using Active Directory for a couple of years, or maybe you have Google accounts with groups and stuff or whatever, all set up. So that's where your organizational structure is, and you have tons of other, not even end user facing, but just like business intelligence tools, etc., that use those systems. Of course, it's not going to be easy to just swap that out. And I would not suggest starting there either. But maybe, as you said, do it piece by piece. And as you then develop new understanding, new tooling, new components, that will make it easier. And maybe, I don't know, it actually winds up being the case that you actually keep your identity provider for the foreseeable future, wherever it is, because it's just plain easier that way.
Because you, Alice, is in your compliant Kubernetes offering, you're using the service DEX.
Yeah.
When we're talking about identity, what about that?
Yeah, exactly. So it's a federated identity provider, which essentially means that you can have your users in, say, Google accounts or an Active Directory or some other LDAP compatible service, or a whole slew of others. And DEX will interface with that and then offer an OpenID Connect token out. So then your Kubernetes cluster, in our case then, but also other services that are OpenID Connect compatible, they can consume that token. And they then know that, well, DEX said this user has been authorized or authenticated in this way. So now I can authorize and say, like, well, these are the permissions that apply to this user. So in that way, sure, keep your organizational structure in your Active Directory if you've heavily invested in that. But that doesn't mean that you have to stick around with whatever cloud provider happens to provide your Active Directory service.
Yeah, I would say a little bit some points that I've thought about when it comes to this. And well, of course, the identity provider, and we talked about that, and also use the agnostic tools for provisioning.
Yeah.
You have the whole kind of setup, like Terraform is one such tool, which kind of is agnostic to what cloud provider you're actually building your infrastructure, provisioning your infrastructure to.
Yeah.
And then also, I think one interesting point that I like to stress is also to design services, even internal, as if they were public cloud services. And if we go back to we have had very much relied on like firewalls in organizations, and then we have in front of the firewalls the DMZ, we have the public facing services, and we do all the right things there with certificates, and we have consultants there helping us with that. And then we have the internal services, which can be like a time reporting service or some other kind of vacation scheme service, which is just like not encrypted and nothing. And everyone is reliable. We also found this when during COVID-19 now that everyone needs the VPN tunnel. You need a VPN tunnel to reach your systems. But today, it's really easy to make even the internal services safe or secure, because you have like tools like Let's Encrypt, which make it really easy to provision certificates. You can make them HTTPS, so they are encrypted. You have lots of libraries to just deal with all kinds of kind of make your application secure. We have really good kind of penetration testing tools, which are just like clicking. All the script kiddies out there, use them. You can use them too. They're not hard. It's just to test your application just the way that any hacker would test them. The tools are out there.
Yeah.
So and if you have all the services running like public services, you design them as they can be on the internet, and it's okay. You have them connected with the identity handle, like you said, like Dex or something like that, so everyone is logging in from the outside. Then they can work whenever they want. They don't need the VPN tunnel. It gets so much easier.
Oh yeah, I agree. That's an excellent point. And I mean, that way you are also connected when somebody manages to breach that VPN, because you don't want it to be just a trusted bubble that they get into in that case, because that's just horrible. That's how these really embarrassing security breaches happen. So don't depend on like a border protection. That doesn't make any sense. You need to actually think in depth here. I fully agree. That's
every system.
Yeah, and that's actually one of the things that AWS got very right. I mean, many have read this Jeff Bezos memo, basically saying like you need to start developing your services as if they will be on the public internet, because they will be, or you're fired, essentially. Maybe that's a bit extreme, but it certainly set expectations, let's put it that way. So, no, it's a great point.
I think so. Okay, so then... in your paper, you mentioned the devil is in the technical details.
Oh God, yes.
What are your thoughts about that?
Yeah. Well,
nitty-gritty.
Yeah, exactly. So, I mean, say that you are currently with one cloud provider that has a message queuing service, for instance, and then you move to a different cloud provider that has a different queuing service. Are you certain that they will have the exact same delivery guarantees? Do you have assumptions built into your code that really depend upon the delivery guarantees of one service and that won't actually work that well if the other cloud message queuing service works slightly differently? I've seen this happen, and I've seen how difficult it can be to be smart about these things. And I mean, you and I talked previously, and you mentioned some very interesting things I thought about S3, the object storage service by Amazon, how it was working in one specific way when it was new, and then basically tooling said that, I'm talking to S3, but they were specifically aware of differences. Can you shed some more light on that?
Yeah, it was like Amazon S3 is the oldest service Amazon actually has, and it's a great service. The simple
storage service, I think.
Storage service.
Yeah.
Yeah, exactly. And in the beginning, they implemented that in the States, of course, and had those availability zones there. And then they started implementing them in Europe. And in Europe, they implemented a newer version. And the thing is that this was not really Amazon's fault. It was more like everybody knew that in Europe the newer version is running, and in US the older version. So they didn't even look on the versioning flag on the request. They just said, okay, so this is to European data center, so we're gonna need the version 2 version of the protocol, and this is the American. So they're kind of different assumptions, and this is what it's all about. It's just like assumptions. The message queuing system you're talking about, if you're going to talk a little bit about the details there, right? That what could the differences be? Well, in a messaging queue service, it could be like if you send in a message, how will this message service behave if you have lots of messages coming in? Will it be that it will only send out the message on the other side one time, or could it be several times? And is your application aware that it could actually be the same message is coming several times, right?
Absolutely. And I mean,
one of those.
And one of the points here to really understand why services can behave in perhaps surprising ways is also, you have to think about it from the perspective of the cloud provider. So if you would design a message queuing system for the scale of Amazon, for instance, you would make certain trade-offs that make sense so that you can support millions of users, rather than making trade-offs that perhaps work better for an individual application. But you're not looking at it from the point of view of one individual application. You're looking at it from the point of view of how can we efficiently offer a massively scalable service. And of course, those certain choices will make sense in one setting, and certain other choices will make sense in the other setting. That's rather obvious. And I mean, if you would, taking message queuing service again as an example, I mean, if you would run your own, say, RabbitMQ or NATS or whatever, you would, of course, set it up so that it works and serves your application's needs. You wouldn't have to think about how do I scale this to 1 million users. And also you'd be portable across clouds because, hey, it's the same RabbitMQ or whatever that you're installing.
Yeah. Yeah, there are many more things, and it's always like when you assume stuff, and it can be hard to detect when those assumptions will make it hard, because it's also when it's high load and stuff like that. It's usually then when you start seeing those kind of edge corners. Or
absolutely. Yeah, cases, like you said, do you just send out the message once or possibly many times? To ensure that a message would only be sent out once under high load, when you have multiple servers actually implementing the service, they'd have to synchronize, like, I'm trying to send out this thing. Who else would like to do that? No, you can't, because I'm doing it. I mean, you'd have to have some kind of bookkeeping. And if you don't guarantee that, that's easier. But if you would guarantee
very much
exactly
easier,
once delivery, that's more difficult. Yeah.
But also about the S3, the consistent write and read.
Yeah.
So do you have anything?
Yeah, because it was only this December that S3 moved to what's called strict consistency. So before, it was famously eventually consistent, which was interesting because the guarantee was really weird. If you created an object, then you were pretty much guaranteed that you could read that new object back, because creation worked in one way, but updating worked in an eventual manner. So if I had a file, I could, update it with some content, then immediately try to read from it, and I'd get the old content back, which of course was very surprising if you did not understand that this is a choice made to support a massively scalable service. But hey, others managed to do object storage with strict consistency, and now Amazon also followed suit.
Yeah, our storage service is using strict. The S3 service is using strict.
That's nice. Yeah. Right.
So, and then also the tools that you're using that's supporting your process.
Yeah. Yeah, exactly. That? I mean, we always use software to support some kind of process, right? And if I'm heavily invested in the services of OneCloud, maybe I've made certain configurations to my build system, to my continuous deployment system. There are many such processes that I just, I depend on. I want them to work. And again, you really have to figure out, okay, so what services do I use from this cloud provider, and how do I make myself free from that so that I can migrate somewhere else? And that, I mean, like you mentioned before, Terraform, that's a great tool to have in your tool chain. I mean, obviously, your Terraform files for deploying an application or deploying your infrastructure on one cloud will not just easily translate into that of another cloud. That's obvious. But if you've developed a lot of skills and understanding for such vendor-neutral tools like Terraform, then you don't sit there with your, CloudFormation or your heat templates if you do OpenStack or whatever. You actually have you have tooling and you have support from all those tools, so that you can actually work with different cloud providers. Different settings, but still same kind of tools. So your operational staff, they still understand and they get up to speed more quickly.
So it's very much about understanding how you use the tools, right? What business processes are your tools supporting? And that could be very kind of implicit if you just use tools from one cloud provider. That could be that you don't actually really understand exactly how many of your processes that are depending on those tools and how they work. Yeah,
exactly. So again, vendor neutral stuff. I mean, as you know, I'm a huge fan of Kubernetes. So Kubernetes also helps you kind of ignore underlying differences. So I don't need to ever set up, firewalls or whatever between components using whatever the cloud provider has, because I just assume that if I make a network policy, that Kubernetes will, figure out the appropriate thing to do.
Yeah, but let's talk a little bit about that, because of course it could be a tall order if you kind of invest in one cloud provider that you are using lots of their services and it's working great for you. And then somebody like me or you come and says, hey, try not to do that. And you say, but we cannot host or manage all those services ourselves. But then we just say, but hey, you can use Kubernetes. And that is not the whole solution. What Kubernetes actually does is creating kind of a lingua franca kind of baseline that you can run on any cloud provider. And then all those services that you could just click or enable really easily in a web front end at the cloud provider, those services you can run fairly easily in Kubernetes, at least much easier than if you would do like one virtual machine per service that you set up. So you can actually find good examples on the internet or something like that, or the YAML files example script to how do I deploy a RabbitMQ.
Absolutely. And also this whole operator framework, which essentially means that you get automated processes in your Kubernetes cluster. So you get software specifically written to understand the states that a more complicated piece of software can be in, and offers an easy way to operate that for you. So RabbitMQ, for instance, I mean, there's, okay, so I don't know exactly if there's an operator for that. I just have to assume there is, because it's such a popular piece of software. And I mean, it's going to make it so much easier to self-manage these things, so that you have basically an automated system admin sitting in your Kubernetes cluster, constantly watching the state of the software, and it keeps it running. I mean, complicated systems such as like Kafka or MongoDB, those things, there are great operators for that, developed by the developers themselves. I mean, the developers of the service. So they know how to fix things, the normal system admin stuff, and of course they can automate that. So I'd say don't be too scared of running these things yourself, because essentially you're not going to be running them yourself. And with regular backups, which of course you can set up as well, I mean, really, how difficult is it? It's what we did before. We can still do that. It's not something that went out of fashion, and it's not like it's rocket science to do. So don't be too scared about that.
Yeah. And then also about the hidden costs of migration. What are your thoughts about that?
Yeah. Well, I mean, an interesting thing is, if you look at the pricing models, so you said network traffic in SafeStream is free, which to me, that's awesome, right? In Amazon, for instance, I'm not picking on them. This is their pricing model. Traffic in to the cloud, free. Out, costs you. Okay? So that means it's easy to make more use of their cloud services. It can be rather difficult to pull your data out. It can be expensive, depending on how much data you actually have. I mean, I've talked to research teams that were excited about how cheap computational power was, and they were doing huge physics simulations, and they then realized that, oh, pulling our petabytes of data out, that's actually going to cost quite a significant sum of money. So, of course, that depends on your usage, right? Then, okay, so there's also new software that you will probably be using. So do you need to do training to be able to make good use of that? I don't know. So there are a few different points you need to think about there. Have you talked to any customers about this? I mean, do they, because I mean, again, I think that your pricing model is so simple so that it seems like that's, while migrating to you, it seems like it's less difficult to figure out how much it would cost. But I don't know.
Yeah. We always recommend our customers to build their applications or the solutions in our platform as open as possible, because we want them to stay because they think we have a good service, and not because they're locked in somehow. So we try to, and that's also why I like how we work together with Elastic's with your compliant Kubernetes platform, because that is kind of building a good baseline for doing it agnostically in the platform, and I think that's so that's mainly what we are. But talking about but hidden costs, I would say like the traffic is the most common, but also just what do you need to reprogram and stuff like that. Some of the things that might you need to change. If you have lots of dependencies of the services like we talked about before, then you need to have some development work ahead of you to fix that. So it's all about like inventory, right? Yeah. That's kind of
that's a pretty good summary.
to know what you're running.
That's a pretty good summary. Just really understand what it is you use, and once you do, figure out cost-effective and reasonable ways of replacing those things. And next time around, try to not build yourself into any one particular provider, because it's going to be more difficult to migrate away, or to just, as you said, negotiate. Because essentially, it is a negotiation. And you don't want to be dependent upon the one that you're negotiating with.
Yeah, because also it always goes in waves. We have like from the 70s with the big batch computers, and then they come kind of like workstations where the computing power got in the workstation, the desktops, and then it comes to the internet, and then the cloud services, and then it gets like you're gonna insource, outsource. It always goes back and forth. And if you build your applications like there would be public web services, even if you're running them internally or at some cloud service provider, it's so much easier to adapt to. Who knows what's going to happen in the next 2 years? We don't know. So it's always good to build as agnostically as you can.
Absolutely. That's also the best way to get the kind of features that you need. Because if you're using a managed service by a huge cloud provider, what are the odds that they will change anything to accommodate for your needs? I'd say it's next to zero. Whereas if you figure out that you really need one type of feature, and maybe an open source piece of software does have that, of course you'd want to be able to use that. So, or maybe you could even invest time in fixing it yourself and upstreaming those changes. But you can't modify the way the managed services work, can you? Yeah.
No. Okay, so we talked about this now, and I would just say that I think that we can say that we are kind of finished with our kind of talk here, but we would like to hear if there are any questions now to us.
Yes, please.
Do we have anyone who has raised a question? Okay, so the question is about what kind of services can we replace? What services can we use if we are using a lot of AWS kind of catalog today? Which are the services that we can use? It's kind of a hard question to ask directly, but I think that maybe just like maybe you can give some hints about the most common services and how you could replace them.
Yeah, sure. I mean, let's just look at the infrastructure and up, right? So if you have virtual machines, any cloud is going to give you that. If you have storage needs, such as object storage like S3, well, many cloud providers, including SafeSpring, have some kind of S3 compatible object storage service, right? So then the question can be, okay, so we have a message queue. Yeah, you can find RabbitMQ, you can find NATs. If you, I don't know what you'd.
The database, for instance, RDS
is very popular, obviously. No, I mean there are great Kubernetes operators for figuring out how to run a cluster of, say, MySQL compatible database servers. So that's something you get from like the Percona people. Postgres, you can do the same thing. Tons of great community support there. So, I mean, you're definitely not going to be the first person or the first company ever to need to run databases in a cloud environment. That's obvious. So there's tons of stuff out there in the community that you can use.
But then you have the harder service like Cloudwatch, which is kind of which kind of binds together everything. What do you have in
Cloudwatch? Cloudwatch is great.
So
Cloudwatch and its cousin Cloudwatch Logs. I mean, Cloudwatch does metrics, and Cloudwatch Logs does log handling and analysis. So storage and analysis. You can use Elasticsearch for both of those features if you want. I personally prefer Prometheus and Grafana for metrics. And then I like to do logs in Elasticsearch, maybe because it's just the way that I think about these things, but also because it seems to have a wide community support, and many services also expose their metrics in a Prometheus-friendly format, so you can just easily ingest that. That's not very difficult to deal with on a technical level. But of course, your tooling will change. And that's one of those cloud-specific integrations that we talked about, that if you have a whole bunch of tools supporting processes around, your operators use Cloudwatch as the source of truth for monitoring and for logging data, of course, you have, a bit more of a journey ahead of you if you need to use new tools and develop new processes around other tooling. But I think it's worthwhile to do because, it's going to serve you well, and it's also going to mean that you can leverage the support from the community at large. So I find tons of stuff related to Prometheus and Grafana and Elasticsearch, because basically that's the sort of default cloud vendor neutral observability stack. But I don't know, how many third-party projects do you see that you really feel like, oh wow, I really need to use this, that are Cloudwatch specific, right? Mm-hmm. Not that many that I can count.
We got a specific question about the IAM, the identity provider. If you use that, we touched about that with using like Dex. Could we say, do we have any other system if we would like to take the whole identity management system into your self-hosted system?
Yeah, that's a very, very good question, because IAM integrates with so many things throughout the entire Amazon platform. Basically, I'd say that's one of the key things that's going to keep people in AWS, because they have so many rights and permissions that are in IAM, and they need to figure out how to move that to a more agnostic system. But keep in mind that most open source software does its own role-based access control, and a lot of them are centering around OpenID Connect tokens, so that if you can present an OpenID Connect token, it says who you are, it says what groups you're in, and the software can verify that itself by knowing the public certificate of the issuer of that OpenID Connect token. So yeah, that's one of the more difficult tightly integrated services to replace, for sure, but it's very worth doing.
We're running out of time here now, but I would really like to thank you, Lars, for coming and chatting with me, and for the questions that people posed. And be sure to check out our offerings and on our web pages, and what we're doing, LinkedIn and social media as well, because we post all the white papers there that we write about those topics. And we are really happy that you joined us, and hope that you will have a good day.
Bye.
Bye.